In this lesson, we're going to cover AP Calculus topic 1.14, infinite limits and vertical asymptotes, not to be confused with limits at infinity, which we'll cover in a later lesson. As we've seen in previous lessons, the limit of some functions will go towards infinity or negative infinity as x approaches some number c. We call this a vertical asymptote, and it's a type of discontinuity. Let's take a closer look at how to find vertical asymptotes from an equation. Recall that a rational function is a function that can be written as a quotient of two polynomials. A vertical asymptote happens at a point C when the denominator of our function equals 0 and the numerator does not equal 0. This is because when we divide by smaller and smaller numbers, it makes the y values larger and larger, heading toward infinity. When both the denominator and numerator are zeros with a common factor, then we have a type of removable discontinuity called a hole. Let's look at some examples. Determine any vertical asymptotes from this function. You can see that when x is equal to negative 1, the denominator is 0. Therefore, there's a vertical asymptote at x equals negative 1. Here's what that graph looks like. Try this one. You'll need to simplify this expression to see where the denominator is 0. The denominator is 0 at x equals 1 and negative 1. And at both those values, the numerator is not 0. Therefore, this graph has two vertical asymptotes. Here's what it looks like. Find the vertical asymptotes of cotangent of x. Here's a hint. We can rewrite that as cosine of x over sine of x. This function has infinite number of vertical asymptotes because sine x is equal to 0 at every integer multiple of pi. Here's what the cotangent function looks like. Try one more. Again, you'll have to simplify the expression to find the zeros. Notice in our simplified expression, the denominator is 0 where x is equal to negative 2. And since the numerator is not 0 when x is equal to negative 2, that's where our vertical asymptote is. Now in this case, we have a common factor. When x is equal to 2, the denominator is 0, but so is the numerator. So instead of a vertical asymptote, we'll find a hole.